Alright, so today is going to be our last day working with Skill 23 with just basic verifying identities. We will verify identities in the future, but these are just the ones using the fundamental identities and some algebra techniques. So today we're going to be learning about the technique of using conjugates. So you might remember this from last year, you might not. But a conjugate is simply where you have a binomial. So say we have 4 plus 3i. Then the conjugate of that is going to be 4 minus 3i. All we did was change the sign in between the two terms in the binomial. You can only have a conjugate if you have a binomial. So in the trig world, maybe that's cosine x minus 1. And you might multiply it by cosine x plus 1. Now the purpose of a conjugate is usually in algebra was to eliminate something. So here we eliminated an I. What it does here is, as you'll see in a second, let me change the thing. As you'll see in a second, is it usually creates something that kind of looks like a Pythagorean identity. So let me show you with this cosine example. So whenever I do cosine x minus 1 times cosine x plus 1, and I double distribute, I'm going to have cosine squared x plus cosine x minus cosine x minus 1. And what happens is these middle terms cancel out, and I now have cosine squared x minus 1, which we all know is the same, or okay, I shouldn't have said that, which you will come to see from the Pythagorean identity equals sine squared x. So sometimes multiplying by a conjugate can be very useful. Now this only works if you have a fraction and you multiply both the top and the bottom by this conjugate. Then it's like multiplying by a well-chosen form of 1. So let's do an example so you can actually see this in practice. So this is just what is a conjugate? What is it? Now we're going to actually do a proof. So example 1, say we have 1 plus cosine x all over sine x equals sine x over 1 minus cosine x. So whenever I'm looking at this, I see that, well, I have one fraction over here, I have one fraction over here. If I were to have one of these sides have two pieces, then it might be easy to break apart a fraction. But I don't have one of the sides with two pieces. They're both a fraction. And I can't change them to sines and cosines because they already are sines and cosines. And it kind of looks like they're almost the same. There's a relationship going on here. You can see that this denominator is this numerator, and this denominator is this numerator with the sign change. So there's a kind of relationship there, which is a hint to me that maybe I should pick one and multiply by a conjugate because we've got a binomial here and a binomial here. So really, in this case, it doesn't matter which one you choose. I'm going to choose the one on the right because when I multiply by the conjugate, it's going to simplify my denominator, make my denominator look nicer, which is just a personal preference. It really doesn't matter. So I'm going to choose the right side, sine x over 1 minus cosine x. And what I'm going to do is multiply by the conjugate. And for your notes' sake, I want you to just go ahead and show this work so you know what happened here. So you can see this is that well-chosen form of 1 that I was talking about. This is really just like multiplying by 1. And over here, my reasoning is conjugate. So now whenever I multiply, I already did this exact example up here. So I'm not going to go through all the work of it because you can see that whenever I double distribute, it's going to equal cosine squared x minus 1. So um, that's what I'm going to put on bottom, cosine. Oh, tricky, tricky. I almost made a big accident. These two terms are not like these two terms because notice the 1 and the 1 are first. Up here they come second. That will make a difference. So I apologize. It's going to be 1 times 1 is 1. 1 times cosine x is plus cosine x. Negative cosine x times 1 is negative cosine x. And negative cosine x times cosine x is negative cosine squared x. So again, you can see that conjugate at work. It makes the middle two terms eliminate one another. And I'm going to go ahead and just bring that together in my next step and have 1 minus cosine squared x. So you can see how that's just a little bit different. And this up here in our example notes, this would have been negative sign. I just don't want you to look back and get all confused on that. That was my mistake. So back down to this problem. I apologize. So we just double distributed with our conjugate. It's simplified down to 1 minus cosine squared x, but we can't forget about distributing on the top, in the numerator. So when I do that, it would become sine x plus sine x cosine x. And again, I'm going to do that down here. Sine x plus sine x cosine x. Now I can see that this denominator looks like a Pythagorean identity. And remember what we're going for. We want this bottom to simplify to a sine. This will actually, if we manipulate our Pythagorean identity, I'm going to write that off to the side here. If we manipulate this, we would need to subtract cosine on both sides. So we'd end up with sine squared x equals 1 minus cosine squared x. So this 1 minus cosine squared x is equal to sine squared x. So when I go to my, I'm just doing all kinds of wrong things. When I go to my next step, this denominator is going to be substituted like that. Now I need to go back up here and do my reasoning. So here, all I did was multiply. Here I canceled. And then here I use the Pythagorean identity. And the top's still the same. Okay, so we've got a sine in the bottom, but it's just one too many. We have a sine squared. And we also have a cosine on top, and we have two parts on top. Hopefully you're starting to notice that these are actually very similar. I should not have distributed way up here, because if you think about it, if I factor out a sine x, let's see what happens. So maybe I did one extra step I didn't need to. I'm going to factor out a sine x, and I'm going to have left behind 1 plus cosine x all over sine squared x. So for my reasoning, I'm going to put factor. And sometimes that'll happen. You'll do one too many steps and you realize, maybe I didn't need to do that. And now I can cancel. So now I've got 1 plus cosine x over sine x. And I did that by canceling or reducing or simplifying. And I got what I wanted. So that's how you use the conjugate. It's just another way of manipulating an expression to change into something you might want. Now, on the right-hand side of page 62, I want to show you another one. Okay, I want to show you one that's just a little bit different, so you have some more examples in your toolbox. So this one is going to be 1 minus sine of x over 1 plus sine of x equals secant x minus tangent x quantity squared. Okay, so which side to choose? Well, since we're in the conjugate section, you're probably with me on this, that we're going to change this side. Okay, we want to manipulate this left side to look like this right side. Now we probably could go with the right side, and honestly I haven't done this in advance, so I could end up wrong. It's just kind of an adventure together. Alright, so let's start with the left hand side. 1 minus sine of x over 1 plus sine of x. We're going to multiply by our conjugate on top and bottom. And notice which one I want to simplify. I want that denominator to simplify. So I'm going to multiply by the conjugate of the denominator. Sometimes it might be useful to multiply by the conjugate of the numerator. But here I'm wanting my right side, and it doesn't even have a denominator. So I'm going to rewrite this. This time I'm going to multiply by the conjugate of the denominator. And over here I'm going to write conjugate. Now I'm going to actually double distribute, and be really careful that you don't write anything in the wrong place. Don't try to do too much in your head. So we've got 1 times 1 on top. 1 times negative sine is negative sine x. Negative sine x times 1 is another negative sine x. Negative sine x times negative sine x is plus sine squared x. So we're going to see in the next step that we probably need to combine like terms. On bottom, they should cancel out in the middle. So now we have 1 times 1 is 1. I know those middle terms are going to cancel, so I'm not even going to bother. And then I'm going to have negative sine squared x. And there I can say multiply, distributed, whichever you prefer. So far, not really looking like that left side yet. But let's keep going. So on top, we're going to have 1 minus 2 sine x plus sine squared x. Notice both of these were like terms because they are both sine to the same power, and they both had negative 1 in front of them. That's how I got the negative 2. Now in the denominator, I have a choice. Maybe I should try to change that using the Pythagorean identity. It worked for us in the last one. So if I manipulate my Pythagorean identity, sine squared x plus cosine squared x equals 1. This time I'm going to subtract sine over, so I'll get cosine squared x equals 1 minus sine squared x. So these are what I'm going to use when I substitute. So now I've got cosine squared x in the denominator, and there I used Pythagorean. Okay, so keeping in mind we really want this denominator to actually completely go away. So what I see is we want a tangent at some point, and I see a sine squared over cosine squared. It looks like it might be useful. So let's go ahead and let's break this apart into 3 fractions. Now I know that might not have come to you, but go with your hunches. If you see 3 parts on top and you've got a big fraction, and you just notice that like sine over cosine could become a tangent, and 1 over cosine could become a secant, well then that's a step in possibly the right direction. So now we have 1 over cosine squared x minus 2 sine x over cosine squared x plus sine squared x over cosine squared x. And that's going to be just break apart. So now we can do some of our fundamental identities, like I'm going to do this one first. So it's going to become secant squared x. These are going to remain the same. And it's really tempting to do more than one at a time, but let's stay away from that for right now. So I just did my reciprocal identity. Now over here I see I have a quotient, so I'm going to do that. So I've got secant squared x minus 2 sine x over cosine squared x plus tangent squared x, and that's using the quotient. Okay, so let's just remind ourselves what we're going for. So we're going for secant minus tangent quantity squared. And down here we've got a secant squared, a tangent squared, and something funky going on in the middle. I'm going to bring in something that you haven't seen before, but now that you've seen it, hopefully it'll start to trigger something. We just talked about factoring. And this, as a result, obviously, of factoring something, a quantity times a quantity, and that's where they got the squared. Down here, notice this cosine squared x could be broken apart into two cosines. So we actually have sine over cosine, and then another cosine in the denominator hanging out. Let's break that apart. Hopefully you'll start to see it before I show you. So all I did there was break these apart. Now look, we've got a tangent and it's got a secant. So I'm going to change both of those in the same step because we've already used them up here. So we've got minus 2 tangent x secant x. And I'm going to put reciprocal slash quotient. And we're really, really close to getting something that would factor into this. And this is one of those things that I told you just kind of had to memorize. If you recall, we talked about it. Where is it? Oh, it's right here. It's on page 59. And you can see this resembles what we've got going on, except it's plus 2 instead of minus 2 in the middle. And so whenever they factored, it was plus and plus. Ours has minus 2 in the middle. So whenever we factor it, it's going to be minus and minus, which is going to give us what we want. So we can factor this. It's going to become secant x minus tangent x times secant x minus tangent x. And if you ever have this hunch that you think that it's one of those special factorings that I showed you, do it and then double check it. Secant squared x, yes. Secant x times negative tangent x. It's a negative 1 tangent x. And then we get the same thing again, negative tangent x times secant x. That's where this middle term comes from. And then a negative tangent times negative tangent is a positive tangent squared. And so if we just rewrite that to look like what the original looked like, there you go. And all we did there was rewrite. So a slightly different one, but this is another type of conjugate proof that comes up a lot, and they'll all kind of look like this. Even in your book, there's like a whole bunch of examples, and they all are going to follow the same pattern. You can see here's the one that we just did, here's one that's similar, and here's two more that are similar, and then 54 and 56 are just like my first example. So once you see these, you kind of start to know the process that they're going to go through. So that's all I have for you guys. I'm not even going to give you a practice problem. Just come in ready to work tomorrow, and your test is going to be on Thursday. So make sure that you're practicing some proofs on your own, either out of your book or out of the packet that I posted. Good luck, and I'll see you tomorrow.